Okay, I'm going to go through lesson 1-7's notes faster than I normally would. As all of you know, there was something wrong with the audio in the original recording, and since we're in a time crunch to get this done and out there tonight, I'm going to go ahead and just go through the notes I already wrote. So as I'm going, I'm going to go very fast. You're just going to have to hit pause whenever you need to catch up on your writing. Or if you want to listen until I get kind of toward the bottom and then you want to copy it, that's fine also, however you want to do it. So this is lesson 1-7, distributive property. The first thing we're going to look at is the mental math portion. This is basically just saying that if you were out in the world doing something and you didn't have a calculator on you, how could you multiply this without a pen or a pencil or a calculator? If you notice, the distributive property allows you to say, I can multiply 34 times 100, because we all know what 100 times 34 is, and I know what 34 times 2 is. 100 plus 2 is 102. So I'd be able to distribute 34 to each of those, and then I would have the answer, and I could do that mentally. The other way to look at this is if it was something like 97, then you would have 100 minus 3 to make sure that you get that 97. So we'll try those tomorrow, but here's the example. So 34 times 100 would be 3400. 34 times 2 is 68. And then you add them in your head and you get 3,468. So it's just kind of a little shortcut to know about multiplying numbers like that. And it shows how the distributive property works with it. So you break down one number and then you distribute each. You distribute it to each of them and then you add them together. Or if it was a number lower than 100 or lower than 500 or whatever you were looking at, then you would subtract. So that's going to depend on how you want to get that number there. Okay, the next thing we're going to look at, this is actually example 3 in the book. It's asking you to simplify, and you should probably already know this. Simplifying 2 times the quantity 5x plus 3. So this means multiplication. You learned in order of operations that you should combine these first, but notice they aren't like terms. They can't be combined, and we're going to review like terms in a few minutes. So because I can't add 5x plus 3, I need to multiply 2 times each of them. So 2 times 5x, 2 times 3, and I end up with 2 times 5 is 10x, 2 times 3 is positive 6. Just remember you're distributing to every term. This is a term and this is a term, and we're going to talk more about that in a few minutes also. So if I had had 5 terms in here, I should have multiplied 2 5 times. Don't forget about the very last term. It seems to be a common mistake. Okay, this one right here is the same exact idea. We have a quantity here that can't be combined, and then we've got it multiplying to something. The only difference is the multiplication's on the right side instead of on the left. Don't worry about that. You're still just going to distribute 1/3 times 3b, 1/3 times negative 2. And once you distribute, 1/3 times 3 just becomes 1b, negative 2/3. And if you're not sure how I multiplied that, ask me tomorrow. Alright, there's something else you're going to come across sometimes. This is really important, and it's about distributing a negative. So the deal with the negatives, distributing a negative here, is that you treat this negative like it's a -1 and you're just multiplying each thing. Or if you notice, whenever you multiply by a -1, all that happens is your signs change. So negatives become positives, positives become negatives. In this case, we have 2 positive numbers, so when you rewrite it, you're going to end up with a -2 minus 6, or you can think of it as a -2 plus -6. There's not a right or a wrong there. Either one works. Typically, we write it this way, though. So try this one. Write down what you have. So it's a negative times the quantity, -4x plus 10. And you should have had positive 4 because this negative becomes positive, and a -10. So 4x subtracting 10. So go ahead and hit pause and copy down the notes that I just went through. And once you're ready, go to the next page. Alright, now we're going to be talking about some key vocabulary that you're going to need throughout the year. Again, I'm just going to go ahead and go through it. Once I'm done with it, you can just hit pause and copy it. So first thing we're going to talk about is a term. A term is a number, a variable, or the product, which means multiplication, of a number and one or more variables. So I'm going to give you some examples of that in a minute. There's also something called a coefficient, Coefficient is the number that's in front of a variable when you're multiplying or when you have a product. So let's go ahead and look at those. First thing I'm going to show you is just the difference between things with one term and more than one term. Here are examples of one term. Here are examples of more than one term. If you notice here, this is just a variable. This is a number and a variable. There's your coefficient, the 2. This is a number and a variable. It's a variable, but it's squared. That's okay. We still have a product. This means negative 2 times x times x. Here we have a negative 1/2 times x times y, product. Here we have 4 times x times y times z, product. No addition or subtraction. Negative 1/3 times x. Or you can look at it this way. If we were to multiply x, it would go up into the numerator, and we'd have a negative x over 3. Still a product because we're looking at multiplying by a fraction there. So those can be a little tricky. So these are all examples of one term. Over here we have examples of more than one term. Notice 4x is a product plus 7. As soon as you have addition or subtraction, now you have more than one term. So there's 2 terms. Here you have negative 3y subtracting 4 plus x. If this subtracting 4 here had parentheses around it, that would all be multiplication. But with no parentheses there, this is subtracting 4. So we have a term, negative 3y, a term, negative 4, and a term plus x. So 3 terms. This last one's a little bit different than over here, because if you notice we have an addition in our numerator. So x plus 3 over 7 actually means x divided by 7 plus 3 divided by 7. This is 2 terms because we have an addition sign between it. Okay, hit pause if you need to. Coefficient, here's an expression for you. It's 2x squared y subtracting 3xy plus 4x subtracting 31. What we're looking at here is just identifying the coefficients and the terms. So hopefully all of you have noticed at this point that you have 1 term, 2 terms, 3 terms, 4 terms. So you've got 4 terms there. These terms have coefficients, the numbers in front of them. This term's coefficient is 2. This term's coefficient is negative 3. You always bring the sign with it. This term's coefficient is positive 4. And this is actually not a coefficient. This is called a constant. There's no variable with it. So a constant is just a number with no variable. Okay, we're going to go on to the next thing. Again, hit pause if you need to. All right, combining like terms. Really important to understand the difference of combining like terms. When you're multiplying and dividing, you are not combining like terms. It's different. We are talking about adding and subtracting. You use combining like terms when you add or subtract things, and what you're looking for is adding or subtracting the coefficient, just whatever it tells you to do, but you keep the variables like they are. And the way I remember that is like terms like they are. The reason I'm combining things that are alike is because I'm not going to change that term, the variable of it. And exponents must be the same in order for it to be a like term. So I'm going to go ahead and give you some examples of that. Notice here we have like terms, 3x and a negative 2x, so they both have an x. Here we have a negative 5x cubed and a 9x cubed, so x cubed, they're exactly the same. These would not be the same. Here we have a 3xy and a 2yx. These are actually like terms because we have an x to the first power and a y to the first power. Doesn't matter the order they're in, this is really the way you should write it because it's alphabetical order. So once you combined them, then you would write it that way. Again, it's because they have the same exponent, same variables. Here's an example of things that are not like terms. 3x and negative 2x squared. Because we have an x and an x squared, they are not alike. 3r squared t and negative 2t squared r. So you have the same variables. You have an r and you have a t. They're flipped around. That really doesn't matter. Here's your problem. This one has a t squared. This one has an r squared. So they are not like terms. Last one, x squareds are the same, but y's aren't. So they're not like terms. and simplify. This is just a basic example of it. 3x squared plus 5x squared. You're adding or subtracting your coefficients. So there's a coefficient, there's a coefficient. I add those up. 3 plus 5 is 8. And I bring the like term over like it was. So 8x squared. Try that one. Negative 5c plus c. I have opposite signs. Don't forget that that's a 1 right there. So you actually end up with a negative 5 plus 1, which is a negative 4c. Combine your coefficient, bring the c over. And there's a last one to look at. 2x plus 5 subtracting 3x. These are your like terms, so I usually underline them or highlight them or do something with them. And so I combine 2 minus 3, which is a negative 1x plus 5. And you don't need the 1 there. We don't have to write 1 as a coefficient unless you want to. Alright, let's go on to the next page. Hit pause and finish copying this. And when you're done, go to the next page. Here's another example of just combining like terms. Notice we have a t squared. I highlighted and I underlined our like terms. I would do either or. You choose one or the other. You can even highlight different like terms in different colors if you have several, or use different marks underneath them. But it's a nice tool just to remind you what you've combined. So we have 3t minus 1t, which is 2t. It does not combine with t squared. So you end up with that. And typically, just so you know, our format would be that we would write the t squared first. You always write the highest exponent first. But for now, it's fine. Okay, here's another one. Just a quick example. If you ever come across something like 4xy minus 3x, nothing is the same here. You can't combine it. It's simplified already. So you just rewrite it as it is. You don't have to do anything to those. And I've already talked about the word quantity. It just means parentheses. So example 6 asks you to write an expression for 3 times the quantity x minus 5. When you see the word quantity, you know whatever comes after it you should put in parentheses. So this would look like 3 times x minus 5. And once you notice that, you should realize you don't need that, and that's what it should look like. There's a chart on page 52 that you're going to use tomorrow for your lesson. And it talks about, let me make sure I'm telling you the right thing. Sorry, let's see. Yes, it talks about lesson 1.8. So in class, you're just going to be able to look at that chart and start to remember those properties of numbers, and that's lesson 1.8. See you tomorrow. Sorry about the confusion with the notes. Hopefully I have the problem fixed on the iPad. We will see.